Hi guys, thanks Kirov for inviting me to speak today. All right, so my name is Rado. I am on the Angular team in Google, and I've been on the team for 2.5 years. In the last 1 year, as part of Angular team, we spun off a team mostly focusing on the internal architecture of Angular inside Google, so supporting the infrastructure for internal teams building on Angular. And part of that, we were one of the first teams to use TypeScript, so we're supporting the infrastructure for TypeScript in Google, and that's the team I've been working on for the last 1.5 years. And I was talking with Kirov about what I should speak to you guys about, and maybe you don't work in Google, you don't care so much of this stuff, but what we noticed is there are a lot of interesting patterns that are happening, a lot of ways of using Angular that we're doing inside. And if you look at it, all the tools that we're using internally are open sourced, and they're on GitHub, and we'll go over all of them. What's missing is really me coming to the stage here and kind of telling you guys about them. And they're open sourced. They are still a little bit rough. So some of them you'll see they're in beta. We need more people to try them, to get feedback and kind of close the cycle and just try to see what works internally, teach you guys about it. You try it to see if it makes sense for you, and so we can keep going. And hopefully the stack that we have internally and the external stack will maybe get closer if it makes sense for you. So let's go through this. So the first thing to keep in mind, some of the things I'll say will be a little bit controversial. This is engineering. We know at the core there are trade-offs. In Google, obviously we are further down this line, and kind of the values that we put into our engineering systems are on this side. If you like the things on the other side, that's not wrong. I'm not saying one is better than the other. I'm not saying we should prefer one than the other. Is just keep that in mind as I'm going through the patterns we're using. Keep in mind that they all are that they're shaped by the desire to support large-scale development, which means we're a lot more explicit. They're less magic. I'm going to try not to use the word magic. Things are explicit. Things are safer because of that. A lot of things are built to be statically analyzable, which the trade-off is some of the more dynamic patterns that the larger JavaScript community prefers are not possible. They're all trade-offs, but they really do help us building in a large scale, and that's kind of what we do in Google. You might not be building at a large scale, but you might share some of the values on the right side of this, so the tools and the patterns I will be showing you would make sense for you. All right, so why I say large scale? Well, writing code inside Google is a bit funny. I don't know how many Googlers we have here. This is, I have a reference. This is public information, but maybe you guys haven't heard of this. I'm not releasing some new numbers here, so yeah, you don't need to. It's not shocking, but it made the Hacker News. It made the rounds like a few months back, and people might have forgotten it. But we do have single repo in Google. One repository for everything, unified versioning, and visible by everybody. That's it. So there's no versions, one giant repo, 1 billion files, only 9 million of them are source files, so lots of data files, 2 billion lines of code, so 35 million commits in total so far. So by now these numbers they're changing, right? They're obviously exponential growth. This was 2015, but order of magnitude is about right, and 40,000 commits per workday, which is around the order of magnitude of number of engineers in Google. So every engineer commits at least one per day. Kirov, did you commit today? Okay, you're adding to the average. So I didn't today, so Kirov is helping me out. Okay. So yes, large-scale development, a little bit crazy. Standard tools don't work for this. We have to have custom tools for everything. Why do we do this? Well, there are benefits, actually. So versioning, like we kind of don't have versioning hell because we don't have versions. Everything is at head. The toolchain is always up to date. There's one compiler used for everything you use. All the tools are standard, and they're always the same for every part of Google that you're in. The code quality, I think, really improves with higher visibility. There are no silos where like some team is trying to hide their code because they don't think it's very good. All code is visible by other teams. They can take a look and decide whether they want to. Maybe you look around and you take some good patterns. Maybe you decide this pattern is crazy. I'm not going to use it in my code. But Google is known for search, and we do have great tools to search across the code base and really see all the code, modify it, invoke, and so on. And again, since it's one repo, it allows us to do big sweeps and clean up the whole code base of a pattern we decide it's not good and really never have it again and never talk about it. So if if we decided using I don't know like dollar scope with dollar scope watch, maybe it's unperformant, we can do large scale refactoring. We can look through a whole code base and decide that we would move away from this and tell all the teams that do that to stop doing it. And we can submit actual pull requests against their code base with the fixes, which it's always, if you want somebody to change their code, it's always better when you come with a pull request than just nagging them. All right. OK, so that's in general about development in Google. Disclaimer: those are the numbers I just showed you. Those are the kind of the only juicy numbers. I don't have any other internal numbers to release. From now on, I only have juicy ideas. No more juicy numbers. So let's talk about Angular in Google. So Angular teams, this is obviously the new Angular. Angular teams in Google use AOT by default, and I'll talk in a second a little more about AOT if you haven't heard about it, but it's on by default. We have a single enforced style guide. So one style guide, everybody follows it. It takes away a whole set of discussions about how to name your files, how to structure your project. The discussions come up front when you're writing a style guide, but once it's written, we just all follow it. Externally, we have some great style guides for Angular that you guys can do basically the same. It's more about having the visibility into everybody's code, and like if you want to do similar pattern in your company, you can do that. We're using Camera Protractor for testing. Nothing surprising there. Playground for framework authors. What I mean by that is the Angular team can see how people are using the framework. And since we have one giant repo with all the use cases and good search tools, we can just go and find how many people are using at input versus at output. How many people are using this API versus this other one? Like, are they using it correctly? Maybe not. It helps. It feeds back into the design of the framework, and the framework gets better because of this. Theoretically, you could do the same thing with GitHub. Of course, a lot of other projects are not on GitHub. So, and the search, I guess, in the larger world of code is a lot harder. In Google, that really helps us that we have this giant repo that we can search and look for Angular patterns that can help us design better. Finally, I forgot to add this to the list, but the big one here is also Angular. There's a single version of Angular in all of Google, and it's always at head. So what's on GitHub head, these big releases that 4.0, I think just yesterday was 4.0 RC1. These big numbers, they don't matter. Internally, we're always at head. We're always synchronized with Google, maybe like 1 or 2 days behind. It means all the teams that are using Angular in Google are using head. It sounds scary, but actually it's a really good feedback cycle for us to know that the framework is stable. And that's something that's, being in Google, it allows us to do that. And something you guys can take as a Angular at head. You're like, well, what if the framework authors just pushed a breaking change? Well, if it landed in Google, there are already all these teams that are using it, even without any release. So we have some good ideas about what works and what doesn't because of this giant repo that we have in in our back. All right, so I'm going to talk a little bit about ahead of time compilation. That's kind of, I think it's one of the new things with Angular 2 that we have it, it might be a surprise to some of you that we have it on by default in Google. The CLI, right, so you can use this externally. I think externally some people are still using it, some are not. Internally, everybody's using it. How many of you know what ahead of time compilation is, AOT in Angular 2? All right, it'll be fun. I think most of you do not. So it's one of the it's a big feature in the new version of Angular that we're very excited about. High level, it means we generate TypeScript out of the templates instead of interpreting them at runtime. So we call it AOT. The old approach, we call it JIT, just in time, just in the browser, just in time we interpret the templates. Angular, the old version of Angular, AngularJS only has JIT, right? So AOT is something that we only enable it now. So this is how it used to work. And this is how, so this is the JIT mode. So what happens here is we have our component, we have our JavaScript, we have our TypeScript first, right? So TypeScript, my component, we write it in TypeScript, TypeScript compiler turns it into JavaScript, put it in some bundle, there's some optimizations, a lot of things happen on the JavaScript side. On the HTML side, nothing happens. It just passed into the browser, and as soon as the browser, every user, when they load your page, they start loading Angular, there's a piece of Angular that would go through this template, and it would try to figure out, oh, look, there's a square bracket, that's a binding, oh, there's a double curly, that's another binding. You would try to parse this HTML template, pull out the important bits that Angular cares about, and only after that, so that's the first step, compile the HTML, only after that, the application starts running. So only after that, the bootstrap happens. So that's how it used to work. What is the obvious optimization here? This compilation step, all the information that went into it, why is it happening in your user's browser? You could have done it as you were building the application. It's like we have the template, we can pull out the important data, we can put it into a format that actually Angular uses. Angular doesn't, the runtime doesn't need the HTML as it's written. It can consume it in a different form, and it turns out that form is a TypeScript file. So this is how ahead of time compilation looks like. The template, we need a template and a controller together, go through a build process, which we call the Angular compiler, NGC. And the template, the HTML file, produces a TypeScript file, a factory.ts. So that file contains all the information that was in the HTML, but it's pulled out into a TypeScript file. And now what we can do is, now we can feed that into TypeScript, do type checking, compile it, and only after that send it to the browser. So that step that happened in the browser, we put it in the build. What is the big benefit? Well, number one is you saw TypeScript, which means the template now it's type checked. So how many of you have done this in Angular 1? Right, so that happens all the time. You mistype a binding, and you don't know. You only see that when it's in a browser. And in fact, sometimes if it's, if it doesn't throw undefined is not a function or something like that, you might actually not even get an error and just show an empty div. So obviously it was a typo. We could have caught it with JIT mode. We're not going to catch it. With AOT, because the template, this bit will turn into TypeScript. Now the TypeScript compiler will check it, and TypeScript compiler will throw a type error. So, and notice it's not just that AOT is linting or parsing the template, it's just transforming it and letting TypeScript do the type checking. So the tool that's best at it does its job. All we do is transform it ahead of time. Hence AOT. So we get one benefit, which is type checking. Turns out there are 4 benefits. So that's why we're so excited about this feature. You get, and they all feel like different types of benefits. It's almost like surprising one idea would give you 4 very different benefits. But you get type checking, so that's good, catches errors. Reduces code size, because that code that had to parse the template, you have to look for the double squigglies. That code now runs as part of the build, so you don't even need to ship it to the browser. So part of the framework now is pulled out. Instead of sending it to the user, we just keep it as part of our build. So second benefit. Time to first render, so that executing that interpreter doesn't have to happen in the browser. First render is improved. And fourth one is you're catching errors as part of your build. Turns out there's very little extra work you need to do instead of as part of your build to make it as part of your IDE, right? So just how TypeScript compiler will give you errors, but also the IDEs that understand TypeScript will show you the red squiggly. We have a prototype for this for Angular language services that will allow you to have errors in your IDE as you're writing your templates. So you get the red underlining as you're writing your template with actual correct information coming from TypeScript, like a real type checking. All right, so that's for Angular. That's for ahead of time compilation. And by the way, one thing to add, it's not on the slides, but with the new release, the Angular 4 RC1 that we released, what happened is, so we reduced code size because we don't need to ship the compiler, but sometimes this factory, if you had too many of these factory files, sometimes if you have too many of them, they would dominate the bundle size. So there was like kind of a breaking even point beyond which it turned out the code size got even bigger. We managed to reduce the size of those factories by a significant chunk. It really depends what you're using, but I think it's something of like, I don't know, 30 to 50%, depending on one of the measurements with it. So that was a big change with AOT that we landed for the Angular 4 release. So that's something we're very excited about, and it makes these benefits even stronger. So it definitely is something to try, and again, coming from Google, we have this on by default, so it's a feature that we are, we are supporting because we have a lot of people using it. All right, next thing, TypeScript inside Google. So as I said, I'm part of the team that also supports the TypeScript infrastructure because Angular team was one of the first users of TypeScript, and we saw it so great, we wanted to share it with the rest of the company, and we spun off a team supporting it. The general ideas are the same. We have large code base. We get economies of scale by unifying things. So it doesn't feel very democratic, but you get a lot of benefits, so it's worth it. We never argue about code style. How many times you guys argued whether there should be arguments on the same line, or you should have a new line for arguments, or CNR, if and else style, and all that? So that's out of the window. We picked one formatter, Clang formatter. It's actually for Clang. It's for C++ originally. It has a version that works for JavaScript and TypeScript. The code style, the white space style, whatever Clang format says it's correct, that's the correct one. We never argue about it. It's in the past. Every change you submit automatically runs through this. So that's nice. We have single set of compiler flags for all TypeScript written in Google. That one is a little controversial. It has, I don't know if you know, TypeScript has around 40 flags. It's a very customizable compiler. Some of them are quite, they change quite a bit. So I think I won't have time to go into details, but some of the advanced ones I mentioned here, I'll show you the slides afterwards. I have more information about it, but one of them specifically, strict no checks, fundamentally changes the type system used in TypeScript. If you have code base where one team uses the flag, the other team doesn't use the flag, it creates this weird environment where you can look at some code and, oh, this works, copy it, paste it in your code base, it doesn't work anymore. And it's very surprising to people, right? It feels like you're writing two different languages. We improve that by having a single set of flags. We ask our users what flags to have on and like what makes sense. We go for kind of more of the stricter side of TypeScript. TypeScript can be, has any type. It has some of the more looser types. We try to enforce a stricter type checking, but it's a single set. Whatever's on, it's on for everybody. Single compiler version, TypeScript 2.1.6 right now. We upgraded for everybody in a single pass. It takes some time, but again, the whole company, everybody's at one version of TypeScript. It's very beneficial. And single configuration for TSLint. We use TSLint on every commit too. All right, so here are the advanced options. I think I won't have time to go into any of that, but if you have, I'm very excited about this, but I don't have time to talk about it. Come talk to me afterwards if you want to know more about any of those. We have them all on by default in Google. They're all off by default with TypeScript. So if you do TypeScript -init, they're all off. We turn them all on. It's a good idea for large code bases. They do catch bugs. All right, so here's the one that maybe will be the newest to you guys. We have a build system in Google, and you can guess what's going to be the idea. It's one build system for everything, like the topic of, I keep repeating myself, but yeah, like we get economies of scale, we get benefit by using one thing everywhere. Internally, it's called Blaze. Externally, they had fun, they renamed it. It's Bazel, we just moved the L. It's open sourced, yeah. It's open sourced. It's in beta open source. Most people in front end, I think, never heard of it. How many of you heard about this? And they're not Googlers. Yeah, exactly. Yeah, no, but it's out there. It's like all the documentation's there. It's actually it's usable. It's just we need more talks and we need more people trying it and kicking the tires and seeing. It's one build system that builds everything. So from Java, C++, Python, Go, JavaScript, TypeScript, it's the same build system for everything. It's basically, for those of you that are like older, like me, that use make, it's like make, but done right. It has no significant tabs, and like the syntax is sane. The concepts are very similar. It does one thing, which is build. It doesn't do anything fancy. It's just a build system. It doesn't try to run a web server or do hot module reloading or anything like that. Here's like a quick example what it does and what it's good at. So this is an example JavaScript project or front-end project. Right? So you have a bunch of TypeScript files, a bunch of Sass files, a bunch of tests. All of them need tools, right? So we used to live in a world where we can send files straight to the browser. That world is gone. I think we all agree we'll be transpiling things because there's always new features coming. We always want to be a little bit ahead of what browsers are. So all of these files need transpilation. So what do you do in Blaze, in Bazel? You describe the dependency. So you have these files that come in, and you say, by the way, these files produce these other files through these tools. So the tools go in the edges of the graph, the files go at the nodes. So at every edge, there's a tool. You describe this dependency graph without running any of the tools. And that's kind of the key point here. So instead of interleaving, I'll be executing code, and as I'm executing, I'll be figuring out what to do next. No, you figure out what you need to do without doing anything, and only then you go and do it. So this is the first step. Well, we need some more. Maybe we need to put our JavaScript into one big bundle. We have to do that to optimize. We cannot load every module one by one. We use Clojure compiler for that. I'll talk more about it later. But what's important, again, is the tools go on the edges. The files go at the nodes. And then at the end, we put all the files into these big bundles of data that we send to our dev server or to our production server. All right, so the tool allows us to describe this graph. And once we have this, we enable the golden rule. And the golden rule is if at least one input has changed, and I want to know if something has changed and I want to redo the whole world, I don't need to change things unless their inputs have changed. If at least one input has changed, redo the work, do the recompilation. And now we get incremental builds that are guaranteed to be the fastest possible. And this sounds a lot harder than it looks because we're always tempted to have kind of a side channel and have another way, like, not expressing all the information about the inputs. So one of the key observations is the compiler itself is an input to this build step. All right, and now here's the magic. I want to do an incremental rebuild. Only I've touched one file, and I'm like, which one should I rebuild? And the answer is always rebuild all. Bazel will figure out what needs to be done, right? So you never have to. You touch whatever you want to touch. Say rebuild all. So in this case, I've touched only one TS file. I ask, let's rebuild all. So a very natural thing. What do you do? What does Bazel do? It goes through the graph and rebuilds all the things that follow from the one thing I touched. So again, it's shockingly simple. Again, no magic here. It's just when you want to have this system work over all the tools that ever you have, it gets a little bit tricky, and it does work. And here's the second thing you can do is all these things, all the changes have to happen sequentially. But what if I also touched a SAS file? Well, now we see we have a parallel flow in the graph. So Bazel can parallelize the work and start rebuilding the style CSS in parallel with components, bundle, and only when they have to rebuild production data, you'll get the synchronization. So you get parallel builds, reproducible builds, and incremental builds in a very nice way, I think. And here's how actually the Bazel file looks like. So this is, like again, if you use Make, if you use other systems, you might think the ideas are not very new. The syntax, at least, I think that's a big improvement over Make. It is basically Python inspired. It's not you don't want the full power of Python, but it looks like Python. I'm missing a parens, so obviously this is not quite. I haven't run it through actual Bazel. It has syntax. You'll complain if you have incorrect syntax, but it's pretty reasonable, right? So this describes the graph. You describe it statically before running any compilers, before running any tools. So that's kind of the big difference from the tools that we use to in the JavaScript ecosystem, where everything is very dynamic. And one final thing about how we do TypeScript compilation with Bazel. So this is an example where we have component A, component B. Maybe they don't depend on each other. We just have those two. Component C depends on B, so it imports B. At some point, you have too much TypeScript. So right now, you can feed all the TypeScript through one run of the TypeScript compiler. It's all fine. At some point, you have thousands of files of TypeScript. You cannot do a single run of the TypeScript compiler. So what can you do if you reach that? You can try to first build two of them. So you build, you pass to a TypeScript compiler, component A and B. You get a JavaScript back. And now the question is, how do you build C? Right? Because C depended on B, but B already got built. What do you feed into the compilation of C? Well, again, this is a very standard trick, but TypeScript has this magic -d flag. So if you haven't used that, that would create a TypeScript .ts file, a declaration file, which is enough to describe the type shape of B, but without feeding O of B. So now we can use that together with C to produce c.js. So again, if you've done C++, header files, nothing new here, but all the features are there. And this is how we build very, very big TypeScript compilations in Google by using the .ts files. And since this all is described through Bazel, if you only touch, let's say, B, but you don't actually change the public interface of B, the rebuild for C does not need to happen, right? Because the .ts file is the same. So you get very nice incrementality. You don't need to encode any of these smarts into your TypeScript plugin or it's all part of the dependency graph. So the trick is just to explain the dependency graph to the tool. The tool is generic, and it just does the right thing. And of course, it's important that TypeScript has this feature of, as you're compiling, also produce the .ts file for the next compilations. All right. Like I like to think of it as the JavaScript build systems currently, that most of the ones we're working with have no static analyzability properties, just how JavaScript doesn't have much static analyzability. TypeScript gives you this ability, and that comparison is very similar to what Bazel allows you to do versus current JavaScript build systems. So TypeScript to JavaScript similar to Bazel to JavaScript build systems. Reproducible builds, I don't know how often you guys in your current systems do. When I work with NPM, I often have to remove node modules. You guys do that? Yeah, that's what I mean by just in case. I just need to clean up just in case. Bazel makes this a lot less likely, because it's if you're expressing your dependencies correctly, you don't need to clean up just in case, right? That's the failure mode of your build system. If you're doing that, your build system is not good. It has some issue. Minimal rebuild paths, incremental rebuilds, and again, this is the build system we use for everything in Google. So it's interesting to take a look. It is, you don't need to take my word for it that it's expressive enough. It's expressive enough because we use it for everything. So it has just the right expressivity to build any language you want to build with it. All right, and finally, part of our story. So we started with Angular, we had Bazel, A, B, C is the closure compiler, and that's the tool we use to optimize. So TypeScript's great, but TypeScript doesn't have a very good optimization step. TypeScript can bundle your things with dash, it can output everything into one file, but it's not very minimal file. So we use Closure for bundling, optimizing. Again, great tool. It's on GitHub. Most of you will try to use it and will get scared and run away because it's a very advanced tool, and we need to do more of explaining what it does, why does it do it, and why it doesn't sometimes do what you expect it to do. But it is the most advanced optimizer for JS right now. And don't take my word for it. This is so one of our contributors, Mark Laval, has built this great tool where it's kind of like a matrix of all the possible tools in the JavaScript ecosystem for optimizing, tree shaking, bundling, and AOT for Angular, lazy loading. And he's running, he kind of, not every, it's supposed to be a hover. He doesn't run it like every day. So I think he runs it once in a while on demand. But he only has one, I don't know if you see it, it's super tiny. Only in the last run, he managed to hook up Closure compiler, but you see where it is? It's in a, it really stands out from the pack of other tools. So it really does some optimizations that are just not accessible to other tools. Not that they cannot add them, it's just, again, it's a tool that we've been using internally for many, many years, and it just has some ideas that haven't caught up. So this is the code size, by the way, so smaller is better. All right. So that's a great site. I'll show you the slides at the end, so I recommend everybody take a look at it. I was thinking like what to show you about how Closure works, but I decided just to show you. So there are many, many different passes inside Closure, many optimizations. So I'll just show you a little example. And so this is using everything that's open source. Right now you can start. So this is a Bazel file and the Closure rules for Bazel. So this is how it looks like. I have just two files. One is awkwardly named class. Somebody came from Java and decided to write constructor factories and very long names. If you're having classes with long names and you're not renaming that, if you're not optimizing through Closure, this will start to weigh you down. you have some methods. So this is one module. You have a second module, which imports the first one, constructs the class, and calls one of the methods. So the second method says delete me. It is not. It's supposed to be deleted. So let's save this, and if I have my terminal. All right, so Bazel build all. So this is the part where I just say build everything. I don't know what changed. I changed something. I don't want to think about it. You figure it out. And OK, so it took 2 seconds. If I run it again, OK, so now it knows for sure that nothing's changed. So the second time it just takes 0.1 second. And here is the final output. So bundle.js. So remember, we started with 2 modules, a new class, a bunch of very long names. It really trimmed it down. One can argue it can trim it down further, but I think this is already pretty impressive. The whole notion of modules is gone, right? So like all the modules are inlined into one file. Yeah, so it's just a demo, but you can. What's more important is this is available. You can start playing with it, and you can see why it beats all the other tools right now. There's always downsides. What's the downside? Well, I'm doing something dynamic. If you do some crazy dynamic module loading, all the modules are completely missing from the runtime. Right? So the names of the modules, it used to be called parent module, child module, all the ES6 modules, they're gone. Right? So if you want to do dynamic stuff, that's not there, but you get a tiny bundle. So to wrap it up, so that's our setup. Like I think I went through basically all the pieces. Good news, everything's open source. Bad news, we haven't open sourced the plumbing, right? So right now, one thing I couldn't show you in the demo is the actual TypeScript with Bazel. We haven't open sourced it yet. We are working on it. So far, one of the best things to start off is Alex Eagle on our team has a demo that uses Clojure for bundling. That's kind of the demo where the graphs that you saw from Mark Laval, they use similar setup. So that's out there, something to take a look and play around with. So yeah, our setup, we want to work forward to kind of put it out there and see if you guys like it. If you want to use it, it is very different. It's very different from Webpack and NPM, and a lot of the tools are different, but they work for us, and they have nice properties at large scale. So yeah, it's thanks for listening, and yeah.